Year 11 Chemistry Mock Exam, question 2. So our first question is quite a common one they like to give you. They like to give you a picture of an unknown salt and ask you to look at the picture of the giant ionic lattice and to determine the formula from that. And all you've got to do is take a pair of things. You just got to take a pair of things to work it out. So we just basically have FeS2. It's a straightforward interpretation. We've got a simple atomic structure question where we've got iron 56. 56 is the mass number and 26 is the atomic number. So the number of protons is going to be equal to the atomic number of 26. The number of neutrons is going to be the mass number, 56, minus the atomic number, 26 is 30. Don't need to show the working, but I'm showing it for completeness. And since this is going to be an atom, it means it's uncharged, so we need the same number of electrons as protons because they're negative 26. Give two differences between iron and sodium. There are lots of different ones you can have here. Ideally, for good practice, you should try and say something about both of these. So it's very similar to the biology questions when you're talking about the differences between eukaryotes and prokaryotes. You need to say iron is this, sodium is this. So we can say iron, you can actually spell. Iron is hard. Sodium is soft. You could have also had iron is more dense and sodium is less dense. Iron is less malleable. Okay. Sodium is more malleable. Iron is less reactive. Sodium is more reactive. There's another one. I'm going to go for iron forms coloured salts. Sodium forms colourless salts. And actually, of course, the salt provided by the iron the colour depends on the iron we're having. So if it's iron 2 or iron 3, which isn't important for this question. So we've got this question, nickel is extracted from nickel oxide by reduction with carbon. Explain why carbon can use to extract nickel from nickel oxide. It's actually quite a good idea for this question to go ahead and write a word equation for this. So I'm going to write that. So we get nickel oxide plus carbon goes to carbon dioxide plus nickel. Exactly the same as you would with copper or with iron. Now we can actually put this into words. The more reactive carbon, so it's more reactive, displaces, and that's a very important keyword, displaces the less reactive nickel to form nickel solid and carbon dioxide. And this would be the same for any metal that's less reactive, any metal oxide that's less reactive than carbon. So iron oxide, copper oxide, all of those would be fine. Question 2.5, straightforward maths question. I'm going to write the formula out again. And you'll see why in a minute. It's actually quite important, I feel, to write the formula out again and show you working under the formula. I'm going to space the formula out. Now, atom economy is the process of finding out the percentage by mass of useful atoms. So the most important thing here is identifying what is the useful atom. So our useful atom, the atom we want, is nickel. we don't need to worry about the carbon dioxide. So we start by working out the MR, okay, of each of these compounds. And nickel oxide is 75. It's already told us that. We don't have to do that. So 75, and carbon is 12. So the total mass of the reactants is 75 plus 12, which is going to be 87. Now the mass of the nickel on its own is 59. And we don't need to worry about the mass of the carbon monoxide. So we need to express as a percentage how much nickel we've got in comparison to how much mass we had to start off with. So we need to do 59 divided by 87 times 100. And if we put that into a calculator, then we get, let's just do that, 59 divided by 87. We get 0.67816, writing a full answer. Oh, times 100, so it's going to be 67.816. And I'm going to write down here to 3 significant figures, because that's what it's asked us to do. But it's important to write the whole thing that you've got from your calculator. I can even add 092 there if I wanted to, because you're showing the step. You're showing the step to go into 3 significant figures. So actually this is worth 1 mark, this formula here, that's worth 1 mark, this is worth 1 mark, and the rounding to significant figures to get 67.8 is worth 1 mark.